VX 2.5. I think we've got most of the people on. All right, so my name's Sherwin Davenport. I'm an AE consultant with Mentor Graphics, working today with Oasis Sales. Oasis Sales is the company who's putting on this presentation today. They're the one that sent out the invites. So feel free to contact them if you have any questions afterwards for sales questions. But as I said, today we're going to be covering what's new in HyperLynx VX 2.5. So I'll go through the slides here on this and tell you what's going on. We're planning on about a half hour for the entire webinar, so not too long. So the VX 2.5 release themes, there were a few different things we focused on. One was an integration between the HyperLynx Advanced Solvers and the Xpedition AMS simulation tool. And I'll talk a little bit about that so that makes sense what we're doing in that space. Then there were many other general and ease of use improvements that were made to the tool, and I'll highlight the most prominent ones of those. And then other things that we worked on were robustness. So, you know, looking for defects or other ways to clean up the simulation flow. Some of the big areas we're focused on were the SERDES channel compliance tools and the power aware. Those were new options, and we wanted to beef those up even more. And then, as you can see down at the bottom here, we had many defects in different areas that were resolved. A lot of these were customer requested defects, and then there were a list of our own that we got fixed up. So that was kind of the focus on this one, is really just ease of use and fixing the defects. We kind of do that every other release. We'll add a bunch of new functionality, and then the next release we'll just go back and work on bugs and ease of use issues. So this is the one in between the big interesting stuff. So but there is the one at the top, which we'll get into first, which is the HyperLynx Advanced Solvers and the AMS integration. So if you're not familiar with Xpedition AMS, it's not a HyperLynx tool. It's a SPICE simulator. At least most people use it as a SPICE simulator, although it actually does a lot more than just SPICE. It can handle digital, mechanical, software, and control code, and simulate that all together. So pretty powerful schematic-based SPICE simulator, if you want to simplify it. But as I said, it does a lot more than that. This issue that we're addressing is really in the SPICE realm, where you have interconnects in an analog design, and you want to get the transient effects, the transmission line effects that are going on in between the interconnects. Usually with those slower analog, you don't really care too much about those aspects, but there are some situations where the frequencies are higher, or form factors or just such that that these interconnect issues become part of the problem. And we've been working with that in a number of ways. Now we've simplified the process of getting that transmission line data back to the SPICE simulation, incorporating it in that, and making that easy for people to simulate that full system that way. There were ways in the past where we would go into tools like HyperLynx. HyperLynx has the ability to export out SPICE models or S-parameter models of traces and interconnects, and then you can go back and try and put that into the schematic itself. So it was a bit convoluted. There was a way to go about it, but now we've simplified that process drastically. So this is an example right here, 100 megahertz low pass Chebyshev filter. Being a filter, you're kind of sensitive about the values of the inductance, the capacitance, the resistance of the circuit, and of course the transmission lines have some of those values, and typically they're being ignored, and so we want to get that into the simulation itself. And you know, just like digital signals here back in the analog realm, if you add in those additional inductance and capacitances and resistances, it's going to modify your waveform. So here's an example of seeing in green we've got the ideal waveform, and then red we've got the modeled interconnect simulation. So a bit different, and we want to include that. So the way that we are getting the transmission line data, we're actually using the full wave solvers, and there's a couple different options of which ones you can use in the full wave solver space. There's the quasi-static fast 3D solver, or the full wave 3D solver, or the hybrid solver. So it depends on how much accuracy you need and how fast you want to get the model for those transmission lines. For the frequency ranges, we're talking the hybrid solvers probably adequate, but the option is to do a lot more. So let me just show this real quick, and then we'll get into the classic HyperLynx stuff. So here's an example of the circuit we were looking at. We've got all the filter components here, but we want to include in the transmission line modeling for this. So to do that, I simply need to come over here and click on the extract parasitics option, and that brings up an additional window here showing me all the nets that are currently selected. And then I just need to, well, this is assuming we've routed the board, so there needs to be a CCE file from the routing. We can tell it to export this, and it'll actually go to Xpedition layout, generate the CCE file, and then just point to that. Or if you've done it in the past, you can just point to the existing CCE file. You choose which solver you're going to use to generate those transmission line models and the frequency range, and then hit OK. And once that's the schematic really doesn't look any different, but in the background we will include those models in there. So again, previously, if you were generating those in HyperLynx and creating like transmission line models, we'd need to come back and modify the schematic to put those transmission line models in place in between the circuitry. And now that's no longer necessary. So, and you know, real easy, just a few button clicks to make that happen. So I'm guessing a lot of you, this was not your concern. You're thinking HyperLynx, you're thinking high speed, but this is just another area where we've advanced the usage of the HyperLynx tools. So let's get back then to the items in HyperLynx. Let's talk first about HyperLynx DRC and the updates that happened there. So with HyperLynx DRC, there were some rule updates, some in the signal integrity space. So just go through these reference checks for traces versus specific power nets, min-max routed comp to comp length, adjacent layer routing, parallel coupling check, and trace width check in BGA areas versus pin pad width. Maybe by the title it may not make sense what all those are doing, but we actually got a picture on the next screen that can show you a little bit of that. We did some in power integrity, ESD, and safety. So again, I said we got a picture for these. So there's 8 rules. 6 of these will go into the standard, and 8 for the developer. But for safety, we've got solder mask clearance checks, silk clearance, power integrity. There's some stitching via checks that are put into place, and then the MC, we've got component alignment there, and then for SI, reference layer checks, net lengths, and vertical parallel routing and trace routes. Anyway, so always advancing in that space and adding new rules. for the next section, before I get into what's in 2.5, I thought I'd back up real quick and just take a couple slides to mention what came out in 2.4, just in case you missed that. So the first item was the power aware. So this is for DDR4, DDR5 cases where you've got large buses that are going from one place to another. They're toggling all at the same time. They have a lot of vias that are close to each other, and the return path may not be ideal. In the past, when we're simulating that in HyperLynx SI, we're kind of assuming that all of this is taken care of some other way, and then it's more or less perfect. But with DDR4, DDR5, it's important to make sure that we're getting that all together. So we have ways now to extract models for the via-to-via coupling and for the PDN, including PDN, so that we can model simultaneous switching. So that's what that is. And so that came in 2.4. 2.5, we added on to that a bit. With the other thing that was kind of big in 2.4 was the compliance wizards for SERDES. This is where you can analyze an interconnect on a high-speed differential trace based on the type of protocol you're using. In this case, you can see down here it's Ethernet and the type of Ethernet. So these are all JEDEC standards. So it's standardization of what an interconnect needs to meet in order to properly get the signal from one end to the other. And we can quickly analyze any type of interconnect, well, a lot of different types of interconnects. We're adding to that list here. So that came out in 2.4, and again, there were some things in 2.5 adding on to that, but I just want to point that out there real quick. So here are some of the examples of the things that we do cover with that. So Ethernet, fiber channel, PCIe, USB. All right, so moving on to what's in 2.5 now. Back to that SERDES compliance wizard, we added in Rev C of the JEDEC standard listed up there. So short, medium, and reflective. So those are now in the as options in that compliance wizard. Another thing to help out with the extremely high speed was getting 3D models, accurate 3D models, and there was an area there where some additional tweaking needed to happen for BGA connections, and so we've improved the area export formulation for those. So that's part of the HyperLynx gigahertz, using the full wave solver to generate the 3D models. And again, a lot of these are just going to be ease of use and bug fix type things. But so there's another ease of use, adding the ability to look at TPS files in the iDensity viewer. So these would be created during the IVS AMI analysis. So you have to generate those scope files, bring those back into the viewer, and compare them. The generic batch simulation been around for a long time. Now we've got some more updates to that. There is an audit pass that can happen now, so you can run just the audit just to make sure that models are lined up and things are ready to go before you set off a long simulation. So that's ease of use improvement there. Showing waveforms now from the generic batch. So you get the batch simulation, it tells you that you've exceeded some overshoot values or whatever. You can easily pop up the waveforms now and view how that looks. All right, another addition was cumulative trace coupling thresholds. So this is a good example down here in this picture here, where we've got a couple traces that are running side by side for quite a ways. They should be coupled, but there was just this little blip here, part of an accordion or whatever that was going on there to match the length. And so the the 500 mils length that we were looking for never actually happened. But if you added these two areas together, we get the 500 mils. So we do see those now as coupled instead of not so. So anyway, that's the cumulative trace coupling threshold there. INI support. If you use INI files, they're pretty nice for keeping track of which models go with which simulation set. And we've got some better ways to control, making sure we find the INI files that you're interested in for a particular simulation. This next one has to do with the DC drop simulation on the power integrity side. Previously, when you run a DC drop simulation, it just dumps all the results in the same spot, and you kind of lose your previous results. So now it's doing the same thing as like the DDR wizard and some of the other wizards. It's going to generate a folder with the timestamp on that when you run that simulation, so you still have access to the previous results. Scripting improvements. So this is, well, it's scripting. A lot of people may not be aware that we do have scripting with HyperLynx tools, and I'm talking HyperLynx SI, PI particularly, because in the past these tools have been typically run just through the GUI, but for the last several versions we've been adding in scripting, improving that, extending that. So it's something that if you have procedures that you do over and over again, or you want people to be able to do certain functions and they don't really know the setup, and you want to just automate the process, that's where scripting can come into play. But we've added additional commands to that, and support for the touchtone viewer and the power scope, so they can actually launch waveforms. And again, we see people using this where they have users who may not be so experienced with HyperLynx, but they want to get some of the benefits out of this. One example I've seen recently would be to maybe run a crosstalk analysis for the HyperLynx DRC, again using scripting to do that, taking the results from the DRC analysis and going to the full HyperLynx SI tool, running some simulations and taking actual measurements on crosstalk to see what the actual results are. And then those that failed that go back again to HyperLynx DRC and with more stringent rules run it again and come up with a final report of which nets have crosstalk issues based on both simulation and the HyperLynx DRC tool. And all that ran with scripting, so it turns into just a simple wizard type flow to go through and come up with those results. Anyway, so some advancements there. That pretty much covers it. There were some, as I mentioned, there were a lot of other defaults that we're fixing and things of the advanced solver space. But so I encourage you to get on and look at HyperLynx and kind of browse around to these different areas that I've mentioned and see where we've improved the tools. Now, I guess I should reiterate, some of these were customer chosen defects, I should say. So if you're not familiar with mentor ideas, I suggest you go look into that. That's actually under support net. So if you log into the Mentor Graphics support net, down at the bottom of the page, kind of the bottom area, there's a link to ideas where you can select the tool that you're interested in, look through the ideas that other people have posted for a particular tool. You can vote on those ideas, or you could submit your own ideas. So if you think of ways that you want the tools to improve or should function in a different way, that's a good way for you to put those ideas forth. So that's, again, a pretty small list of exciting things to look at, because again, this time we're focused mostly on defects and ease of use type improvements this time around. So it looks like we're actually ending a bit early, just by a few minutes. If there are questions, again, please contact Oasis Sales. If you want to contact me on technical questions, my email address is Sherwin_Davenport@mentor.com. Again, that's Sherwin_Davenport@mentor.com. So just go ahead and bring my name back up in case there's any questions on that. And help out with any technical questions on that. But again, thanks again for your time today, and I hope this was helpful. Let us know if there's things you'd like us to improve on these webinars. Thanks.